Hello dear students, welcome back to physics online class. So in previous session we were discussing about Gauss law. So already I come to know about that Gauss law. So phi is equal to q by epsilon naught. So now we will derive certain applications related to Gauss law. For example, I will take one straight wire here. So on that straight wire the charges are going to be distributed uniformly. So if the charges are distributed uniformly on the straight wire means I will consider certain point here. So for example, I will consider one point, so that is point of observation. So at that particular point what will be the value of electric field strength I need to determine. So in order to determine the value of electric field strength in case of a infinite straight wire, so let me derive an expression for electric field strength due to uniformly charged infinite straight wire. So first I will take one infinite straight wire. So on that wire the charges are distributed uniformly here. So let me take one straight wire here. For example, this is straight wire. So on this straight wire, so charges are distributed uniformly. Okay. So now my interest is to calculate what will be the value of electric field at this point. So let me draw one imaginary cylinder here. For example, for this arrangement, so I will draw an imaginary cylinder here. So in case of that imaginary cylinder, I will choose certain points here. So I will take that three Gaussian surface here. For example, this is one Gaussian surface and this is one Gaussian surface and another Gaussian surface. So this is another Gaussian surface here. So three surface I took it here. So for example, this Gaussian surface d of S1 I will name, and this surface is d of S2 and this surface will be d of S3. For the positive charge, what is the direction of electric field lines? For the positive charge, direction of electric field lines are outward direction. So this is the direction of electric field lines. Let me write the direction of electric field lines. So for example, for the positive charge, field lines are outward direction. So this is the direction of electric field lines. So let P be a point of observation at this point, or in these three regions I will calculate that electric field strength value. So for example, for this first surface I will draw one normal line. So why? Because from the concept of flux, flux depends on phi is equal to E into d of S cos theta. It means that angle between field line and normal line. So this is the direction of electric field lines. So for this reason I will draw one normal line. So normal line is nothing but a perpendicular line. So for this Gaussian surface, this will be a perpendicular line or normal line. So this is the normal line for the first surface. For example, for the second Gaussian surface, so which is act as a normal line. So this line is act as a normal line. For example, for the second surface, this is a normal line, and similarly for the third surface, so this will be a normal line. So for the third surface, this will be a normal line. So now I will apply that electric flux equation for the first region, for the second region and for the third region here. So first I would like to write that consider a uniformly charged infinite straight wire. So if it is a wire means, so that density I can call it as a linear charge density. So consider a uniformly charged infinite straight wire. Let Q be the charge, and so linear charge density is represented by the symbol lambda here, and lambda be the linear charge density. Lambda is linear charge density. Okay. Now I would like to apply Gauss law to the equation or to the surface, Gaussian surface 1, Gaussian surface 2 and Gaussian surface 3 here. So from the Gauss law, I will calculate that electric field strength value here, or first I will consider that flux value. So from Gauss law, equation. So from that Gauss law, so phi is equal to what? So from the Gauss law, phi is equal to E into d of s cos theta. So Gauss law is divided into a 3 regions. So Gauss law is divided. So I took 3 regions here. Divide into 3 regions. 3 regions here. So Gauss law is divided into a 3 regions here. Let me apply for the first surface. Surface integration of E into d of S1. So directly I will take that value here, cos. So cos theta indicates angle between electric field line and normal line, I said. So this is the direction of electric field lines. So for the first surface, so this is the normal line. Then what is the angle between electric field line and the normal line? So here angle is 90 degree. For the first surface, what's that cos value here? Theta value. So cos 90 degree. So then for the second surface, and for the second surface, E into d of S2 cos. For the second surface, so for example, this is second Gaussian surface, look at here. So this is the direction of electric field line and this is the direction of normal line. So electric field and normal line, so both are parallel here. So I will take that angle as a 0 degree here, cos of 0 for the second surface. And for the third surface, E into d of S3 cos of. For the third surface, what's the theta value here? So similarly, so this is direction of electric field line. So this is normal line. What's the angle here? So direction of electric field and normal line. So again it is 90 degree. So that is equal to 90 degree. So from that Gauss law, so phi is equal to what? So phi is equal to Q by epsilon naught. So this is about, for 3 reasons, it is equal to Q by epsilon naught. Here cos 90 means 0. Here also cos 90 is 0. So let me rewrite here. Surface integration of E into d of S. So cos 0 means it is equal to 1. It is equal to Q by epsilon naught. I will take this as a equation 1 here. What is that surface area of the cylinder here, where d of S. So our integration of d of S is nothing but what? Yes. So let me write one more step here. E into surface integration of d of S, it is equal to Q by epsilon naught. So for example, I will take this as a equation 1. So integration of d of S is nothing but a S here, where S is equal to, so surface area of the cylinder, what is the formula? 2 pi r into L here. So what is the surface area of the cylinder here? For example, this is the length of the cylinder and this will be a radius here. So S is equal to 2 pi r, and from that linear charge density, lambda is equal to, it is the ratio of charge per unit length, I said. So shall I rearrange this equation? So wherever Q is there, so Q is equal to, shall I write it as a lambda into L here? So look at here, I got that S value as well as Q value here. So this I will take it as a equation 2 here. So equation 2 value I will substitute in equation 1 here. So let me substitute the value here. So put equation 2 value, equation 2 value in equation 1. So if you substitute the value, E into, what is that surface integration of d of S? That is S. So S is equal to what? 2 pi r into L. So 2 pi r into L here, it is equal to, so wherever Q is there, so Q is equal to what? Lambda into L, where lambda represents that linear charge density. Lambda into L divided by epsilon naught here. So look at here, here L term will get cancelled out. So I want to determine the value of electric field strength here. So finally E is equal to lambda divided by 2 pi epsilon naught into R. What is the final equation for electric field strength due to uniformly charged infinite straight wire here? First I consider infinite straight wire. Let Q be the charge distributed uniformly on that straight wire. So if the charges are distributed uniformly on the straight wire, means that is one dimensional view. So for that one dimensional view, I will consider that charge density. So that charge density as a linear charge density. Let lambda be the linear charge density. First I will apply Gauss law for these three different reasons due to uniformly charged infinite plane sheet. So already I got that if I take that infinite straight wire, electric field strength due to infinite straight wire E is equal to lambda divided by 2 pi epsilon naught into R, where lambda indicates that linear charge density. Or let me rewrite this equation. So or otherwise I will write this equation as a 2 times of lambda divided by 4 pi epsilon naught into R. So why? Because 1 by 4 pi epsilon naught standard value I have. So that is what? So you may write this value or this one. So this equation is applicable for infinite straight wire. So instead of that straight wire, if I consider that plane sheet, then what will be the equation for electric field strength in case of infinite plane sheet? So I will consider one non-conducting plane sheet here. Here charges are distributed uniformly. So if it is plane sheet, means that charge density I will name it as a surface charge density here. So let me consider that point of observation. For example, this is P is the point of observation, and these point of observations are at a distance of R from the plane sheet here. Again I took that three reasons here, first reason, second reason and third reason, and for these three reasons I will apply that Gauss law. So look at here. First, for the positive charge, treat me this is a plane sheet here. So for the positive charge, what is the direction of electric field lines? For the positive charge, electric field lines are outward direction. So this is the direction of electric field lines. For this surface, first I will draw that normal line. So look at here. For the first surface, so this is surface. For this first surface, this is one normal line. So this is the normal line. For the positive charge, electric field lines are outward direction here. So this is the direction of electric field line here. Similarly, for the positive charge, outward direction. If it is positive charge, means so positive charge outward direction. And for this surface, so this is normal line. So for this surface, this is one normal line or perpendicular line, and for the positive charge, electric field lines are outward direction. So look at here. For the first and third reason, field line and normal line are in the same direction or parallel to each other. So theta is 0 degree. For this second reason here, so look at here. For the second reason, so this is the direction of electric field lines. So for this reason, which is that perpendicular line here, so this will be a perpendicular line for the second reason. So for the second reason, look at here. So this is the perpendicular line for the second reason or normal line. So this is the normal line for the second reason, and this will be the direction of electric field line. So for the second reason, angle between normal line and field line, so that is 90 degrees. So let me apply that Gauss law for these three reasons here. So consider a uniformly charged infinite plane sheet, here. Let sigma be the surface charge density. So let sigma be the surface charge density. Here, surface charge density. Now, so now we will apply that Gauss law for these three different reasons here. So apply Gauss law here. So if I apply the Gauss law is divided into three region here. So let me apply that Gauss law here. Gauss law is divide into three region. Three region here. So Gauss law is divided into a three regions. So let me apply Gauss law for these three regions. So for the first region, so E into d of S1. So E into d of S1 cos of. So look at here. So for the first region, what is that angle between normal line and field line? So for the first surface, this is normal line. For the positive charge, electric field lines are outward direction. Both are in the same direction. So theta value is 0 degree. For the first surface, theta value is 0 degree. And for the second surface, E into d of S2 or E into d of S2 or S. So that is, so cos of. For the second surface, so or for second region, what is the theta value here? So look at here. For the second region, this is normal line. Did you get my point? Then what is the direction of field line? For the positive charge, field lines are outward direction. So look at here. This is the direction of field line here. Then what is the angle between normal line and field line for the second surface? For the second surface, angle is 90 degrees. So that is cos 90. And for the third region, E into d of S3 cos. So for the third region, so both are in the same direction. So again theta value is 0 degree here. 0 degree. It is equal to what? So it is equal to Q by epsilon naught here. So look at here. This portion will becomes 0 here. So I will consider E into d of S, or for the first one d of S1 plus of E into surface integration. For the second one d of S2. So it is equal to Q by epsilon naught. So it is equal to Q by epsilon naught. So d of S1 is nothing but a d of S. So E into S here. S1 and S will give the same value. So E into S plus of E into S, it is equal to Q by epsilon naught. Shall I take this one as a 2 times of E into S, it is equal to Q by epsilon naught here. So let me take this as a equation 1 here. So from the surface charge density, so from surface charge density, here. So from surface charge density, so what is the equation for surface charge density? Sigma is equal to what? Sigma is equal to Q by S. Or shall I rewrite this equation? Q is equal to what? So Q is equal to sigma into S here. So this I will name it as a equation 2. So wherever Q is there in equation 1, so shall I fill it as a sigma into S here? So let me substitute the value here. So I will substitute equation 2 value in equation 1 here. So put equation 2 value in equation 1. So if you substitute the value, so look at here, 2 times of E into S, it is equal to what? So sigma into S. So it is equal to sigma into S divided by epsilon naught. So here S term will get cancelled out here. So if S term will getting cancelled out means what's the final value here? E is equal to what? E is equal to sigma divided by 2 epsilon naught. So what is the final equation for electric field strength due to uniformly charged infinite plane sheet here? So for the infinite plane sheet, so I will consider 3 Gaussian region here. If you apply Gauss law for these 3 Gaussian region, if I simplify that equation, finally I will get that E is equal to sigma divided by 2 epsilon naught here, where sigma indicates what? So sigma indicates the surface charge density. surface charge density. So where sigma represents that surface charge density here. So did you get my point here? So now related to these infinite plane sheet, for example, I will consider that two infinite plane sheet here. So these two infinite plane sheets are placed parallel to each other. Let me consider what is the value of electric field at this point. So left side of the plate A, and in between the plate A and plate B, and right side of the plate B. So I will consider that two parallel plate here. So these are all two parallel plate. So I want to calculate that what is the value of electric field strength due to plate A and plate B in three different reasons. So first reason is left side of plate A, and second reason is between plate A and plate B, and third reason is right side of the plate B here. So let me consider that equation of electric field if two plane sheets are parallel to each other. So if two plane sheets are parallel to each other, so first let me draw plane sheet here. So this is one plane sheet. So this is plate A. So charge is positive here, and charge density let me consider as a sigma of A, and parallel to this another plate I will consider. So this is plate B. For this second plate, so surface charge density I will name it as a sigma of B here. Surface charge density I will name it as a sigma of B here. So now let me choose that point here. So for example, this is first reason, and this is second reason, and this will be a third reason here. Now my interest is to calculate that what is the value of electric field in the first reason due to plate A and B, and electric field at the second reason due to plate A and B, and electric field in the third reason due to plate A and B here. So let me consider that 3 point here. So for my simplification I will take that sign conventions here. So negative x-axis I will take it as a negative value of electric field. If the electric field is along positive x-axis, means that electric field I will take it as a plus here. So look at here, for my consideration or for my simplification, if the electric field lines are negative x-axis, that field lines I will take it as a negative electric field. If the electric field lines along positive x-axis, that electric field I will take it as a positive electric field. For example, electric field in first reason here, in reason 1 here, in reason 1, in first reason. So in first reason means what? So that is, first reason means left side of plate A here, that is left of plate A here, left side of the plate A here. So for the left side of plate A, first let me draw the direction of electric field lines at this point. So for example, for the positive charge, what is the direction of electric field lines? For the positive charge, direction of electric field lines are outward direction. For the plate A, so this is the direction of electric field lines, E of A. And for the plate B, so plate B is also positively charged I took. So for the plate B is also positive charge, means so this one is E of B here. So in the first reason, so what is the total electric field? So total electric field E is equal to E of A plus of E of B here. So let me consider what is the value of electric field strength due to uniformly charged infinite plane sheet here, sigma divided by 2 epsilon naught. In which direction electric field is present here? Along that negative x-axis. So shall I take this equation as a minus of sigma divided by 2 epsilon naught plus another E of B is also negative x-axis, minus of sigma of A, and this one is sigma of B divided by 2 epsilon naught here. So I will simplify this equation further. So in these two equations, what are the common factors here? 1 by 2 epsilon naught is the common factor. Let me take out those equations. So look at here. So in this equation, so I will take that E is equal to, so shall I consider this one, minus of 1 by 2 epsilon naught, I will take it as a outside the equation. Then what remains here, sigma of A and sigma of B here. So sigma of A plus sigma of B here. What is the equation for electric field strength in case of that two parallel plates in a left side of the plate A, or in the first region here. In the first region, what is the value of electric field? E is equal to minus of 1 by 2 epsilon naught sigma of A plus sigma of B. So for example, in the second region here, so second case I will consider in region 2 here. So region 2 is nothing but what? Between the plate A and B here. So in region 2 is nothing but, so that is between plate A and B here. So between the plate A and B here. So between the plate A and B, so what's the value here? So total electric field E is equal to E of A plus E of B here. So now I will consider that E value. E of A is positive or negative. I will consider on the basis of direction I said. For example, for that a positive charge here, from the plate A, electric field lines are outward here. So if it is outward means, so this is the direction of electric field lines here. For the positive charge, what is the direction? Sorry. For the plate A, for positive charge, what is the direction of electric field lines here? Outward direction. So for the plate B here, for the plate B is also positive charge. For the positive charge in this direction, so field lines are outward here. So this is E of B. Did you get my point here? So look at here, for the plate A, so field lines are outward here. So field lines are outward means this is the direction of electric field line due to a plate A. And for the plate B here, so for the plate B, so this is the direction of electric field lines for the positive charge. So I said that for my convenience, I took that if the electric field lines along positive x-axis, that electric field is positive. So sigma of A divided by 2 epsilon naught plus of, for that E of B, it is along negative x-axis. So if it is along negative x-axis means minus of sigma of B divided by 2 epsilon naught here. So from these equation, shall I take this 1 by 2 epsilon naught as a common factor here? So sigma of A minus of sigma of B. What is the value of electric field strength? So between the plate A and plate B here, between the plate A and plate B, it is equal to, so E is equal to 1 by 2 epsilon naught sigma of A minus of sigma of B here. So third case. So third case is, so I will choose that third reason. That third reason is, so right side of the plate B. So in reason 3 here. So in reason 3. So reason 3 means that is right side of plate B here. That is right side or right of plate B. Right side of the plate B. So look at here. So in case of that a third reason, so for example, for the positive charge, what is the direction of electric field lines? Outward direction here. So in this point, for example, from the plate A, electric field lines are outward here. So this is the direction of electric field lines for the plate A. And for the plate B, so for the plate B is also what? So this is the direction of electric field line here. So look at here. So total electric field E is equal to what? E of A plus E of B. So what is the direction of E of A? Along positive x-axis. So if it is along positive x-axis means, so sigma of A divided by 2 epsilon naught plus of, what is the direction of E of B? E of B is also along positive x-axis here. So sigma of B divided by 2 epsilon naught here. So finally 1 by 2 epsilon naught. So 1 by 2 epsilon naught sigma of A plus of sigma of B. So this is the value of electric field lines in case of the third reason here. So did you get my point here? So I took point A. So first reason is left side of plate A, and second reason is between the plate A and plate B, and third reason I consider right side of the plate B. So look at here, instead of that similar charges, for example plate A having that positive charge and plate B having the negative charge, its surface charge density in general I will consider as a sigma here. So look at here. So if it is a similar charges means this is the equation for electric field. If it is dissimilar charges means, for example on the plate A positive charge accumulated and on the plate B negative charges were present. So on that plate B if negative charges are present, so look at here, on the plate B if negative charges are present, so then what will be the value of electric field strength in such cases here? So let me quickly write the equation. So first we will consider the direction. In the first reason, this is first reason. For the positive charge, what is the direction of electric field lines? For the positive charge, electric field lines are outward here. So for the positive charge, electric field lines are outward. In that first reason, for that plate B is negative charge. For negative charge, electric field lines are inward direction here. So for the plate B, what is the direction of electric field lines for the negative charge? For the positive charge outward and for the negative charge inward. In case of properties of electric field lines, already we discussed such concept. So if it is positive plate means in the first reason electric field lines are outward. So because of that plate B, electric field lines are inward direction in case of that reason 1 here. So this is the direction of E of B. Then what is the total electric field here? So sigma divided by 2 epsilon naught. So this is positive x-axis, plus of, if it is along negative x-axis, so this is minus here. So E of B is along positive x-axis, so that is sigma divided by 2 epsilon naught, minus and plus, it will get cancelled out. Then what is the electric field in the reason 1 here? In the reason 1 electric field is 0 here. Did you get my point? So next, similarly in the second reason, so in case of that second reason, due to a plate A, field lines are outward here. So this is the direction of field line. So due to a plate B, electric field lines are inward here. Due to a plate B, electric field lines are inward means, so this is the direction of E of B. So look at here, for the positive charge field lines are outward here. Here for the negative charge electric field lines are inward here. So don't get confused here. So look at here, for the positive charge electric field lines are outward here. For the negative charge, what is the direction of electric field line in the second reason here? For negative charge electric field lines are inward here. So inward means this is the direction of electric field lines here. So E is equal to what? So E is equal to, so E of A is along positive x-axis here, sigma by 2 epsilon naught. So next, plus of, so in general I took this one as a sigma, surface charge density. E of B is also in that same positive x-axis here, so that is sigma by 2 epsilon naught. Sigma plus sigma, so 2 times of sigma divided by 2 epsilon naught. Then E is equal to what? Sigma by epsilon naught here. What is the value of electric field strength between that plate here? Sigma by epsilon naught here. So look at, similarly in the third reason here, for example this is third reason. So look at here, in case of the third reason, electric field at the third reason due to a plate A. So for the plate A, electric field lines are outward here. So look at here, electric field lines are outward means this is the direction of electric field lines in the reason third. So because of the plate A here. So because of the plate B, so for plate B electric field lines are inward direction. I said inward means in this direction. So this is electric field line direction. So this is E of B. Hope you get it here. So look at here. So in the second reason for the positive plate outward. So in the second reason for that plate B here. So for the plate B inward direction. So in the third reason, due to a plate A, electric field lines are outward. So due to a plate B, electric field lines are inward direction. So then E of A is what? So E of A is along positive x-axis, that is sigma by 2 epsilon naught, and E of B is along negative x-axis, minus of sigma by 2 epsilon naught. Electric field strength value is 0 here. Look at here, if one plate is positive and another one is negative, electric field in the outer region is 0. Electric field is present only between the plate here. So did you get my point it here? So we'll meet in next class.